Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. If you are new to my channel and not yet subscribed, I will highly suggest and request that you first subscribe to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of the playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. This is in this video I am starting the next chapter, which is Unitary Method, and this is part 1 video where I will discuss the concept of direct variation of two quantities A and B, and will solve some problems, if not all, some problems from the exercise 9A. In the previous video, I solved a practice test paper on the previous chapter, that is ratio and proportion. If you have not watched that video, I highly suggest that you watch that video. You will get a good practice of problems, solving problems on the concept of ratio and proportion. And if you need another practice paper on the chapter, please do let me know in the comment section. I can prepare another test paper. So so let's get started with this video. Okay, so I have my rough notes prepared on the left hand side on the direct proportion of two quantities, and on the right hand side I will do some discussion and solve the problems from exercise 9A. Now in this chapter is unitary method, which unitary method essentially deals with finding the value of some required quantity, where you first find the value of unit quantity of that of some unit amount of that quantity. So now, so basically, say let's say there is a commodity A, and it is given that X amount, X quantity of A is some commodity, some object or something. It is given that X quantity of A costs or value, let's say value is value of X quantity of A is Y, and then you are asked, question is it could be what is the value of Z quantity of A, or it could be what quantity of A can be had or can be obtained for Z value, for Z value. I mean, this is the standard questions are related to commodity and cost. So if we consider A as some commodity that you purchase or obtain, let's say A could be rice, and it is said that you can have 1 kg. It is said that you can have let's say 2 kg of rice. The cost of 2 kg of rice is, let's say, 100 rupees. Then you are asked how many kg of rice can be had in 400 or 500 rupees. So the unitary method, you from the given fact that 2 kg of rice, let's say it is given that 2 kg of rice costs, let's say 150 rupees 150, and you are asked, let's say for rupees 500 how much of rice can you have, or let's say it is asking 5 kg of rice costs how much. So for solving this kind of problem, this is the given fact. This is the given fact that 2 kg of rice, the cost of 2 kg of rice is rupees 150. From this, using unitary method, what you find is, first you find 1 kg, the cost of 1 kg of rice. 1 kg of rice will cost 150 divided by 2. Since 2 kg of rice cost 150, so 1 kg of rice will cost 150 by 2. Now, why we are dividing 150 by 2? Why we are not multiplying? Because, so to understand that, we need to understand two things, that is direct variation and indirect and inverse variation. In this video, we will understand what is direct variation. So the fact that to find 1 kg of rice, we are dividing 150 by 2. This is because the quantity so we are buying some amount of rice for some rupees. So here the quantities is cost of rice and the amount of rice. So the amount of rice and the cost of rice are they vary directly. Meaning, if you increase the amount of rice, the cost will increase, and if you increase the cost, then you can get more rice. So so this is the concept what we call as direct variation or proportion of two quantities. Now let's discuss what is direct variation or proportion of two quantities. Now, two quantities, you can follow the notes on the left hand side. Two quantities A and B are said to vary directly if the ratio A is to B or A by B remains constant. So there are two quantities A and B. These two quantities can be anything. For like in the example of rice, A could be the amount of rice in kg and B could be the cost of rice in rupees, or A could be the cost of rice in rupees, and B could be the amount of rice in kg, or anything else, any other quantities. Now, if these two quantities are said to vary directly if the ratio A is to B varies directly actually means that if you increase B, A will increase. If you decrease B, A will decrease. Or in other words, if you increase A, B will increase, or if you decrease A, B will also decrease. Now, these two quantities A and B are said to vary directly if the ratio A by B is constant. It is said by definition is constant. Now, you can also say this is also equivalent to that. You can also say that the ratio B by A is constant. If A by B is constant, definitely B by A will also be constant. So this is the basic concept of two quantities to vary directly. Now, so two quantities A and B are said to vary. So this is vary directly when their ratio, that is A by B or A is to B, is constant. Now this is known as direct variation or direct proportion. This concept that two quantities vary directly is known as direct variation or direct proportion. And the thing is that you can so vary directly in the notes. Vary directly, if you follow the arrow mark, it means that if A is more, if you increase A, B is more, B will increase, and if you decrease A, then B will also decrease. So definitely if the ratio A by B, if A by B is constant, let's say, so A by B is constant. So let's say A by B is some constant K. This is some constant value, some number. Now, so this implies that A equals K into B. Now, in this equation, since K is a constant, K will never change. Now, if we consider A and B as the variable, if you increase B, definitely A will increase, because K is constant. K is not changing. But so if you are increasing B, A is increasing, and if you are decreasing B, then also A is decreasing. Now, if you are increasing A, then also, now from A by B, we know that A by B is equals to K is a constant, and we can say that A equals to K by B. We can also say that B equals A by K. We can also say that, and so from here also, from the equation B equals to A by K, we can say that if A is increasing, see 1 by K is constant. Since K is constant, 1 by K, this is nothing but 1 by K into A. So if K is constant, then 1 by K is also constant. It is not changing. So if you increase A, B will increase. If you decrease A, B will decrease. So this is the basic concept. Now in problems, while solving problems, the most important thing you have to understand is that the quantities, if there are two quantities which are being talked about in the problem, those two quantities has to vary directly. You have to understand this from the problem. If they vary directly, only then you can apply the concept of direct variation in solving that problem. Okay, so some examples of quantities that vary directly are, if you see the notes on the left hand side, A, cost of rice and amount of rice. So definitely, if you purchase a rice, a particular type of rice, its price will remain is fixed. By price it remains fixed means its rate of price, that is the cost per kg, is fixed. So if you amount 1 kg of rice, it might cost 50 rupees, and if you buy 2 kg of rice, it will cost 100 kg, 100 rupees 100. If you buy 3 kg of that rice, it will cost 150 rupees. So if you are increasing the amount of rice, the cost is increasing. So here C by A, so in the notes I am representing C as the cost of rice and A as the amount of rice, let's say in kg. So C by A, it will be a constant, and actually C by A is the rate of the rice, that is the cost of rice, the cost of 1 kg of that rice. Okay, another example is every object which has a height, it casts a shadow during the daytime. Because of sunlight, it casts a shadow, and that the length of the shadow actually varies from time to time. So at a particular time in the day, the height of that object, the ratio of the height of the object and the length of its shadow, the ratio is same for all objects at a specific time. So if this is an object, let's say this is an object, if its height is h and it's casting a shadow, let's say this, if this length is s, so h by s or s by h, whatever you may say, both is right, is constant. This is constant at a particular time in the day, and this is constant means for any object. If you have another object, let's say this constant is some value k, it's some constant, it's a number, it doesn't vary. This constant is same for a specific time in the day. So if there is another object which has height h, and if it's at that specific time, at that same time, if it casts a shadow small s, then small h by small s will also be k. So this is what it means. So this is the concept that the height for an object at a specific time in the day, its height and its length of shadow is varied directly. That is, h by s will be a constant. So if the height of the object is more, the length of its shadow will be more. If the height of the object is less, the length of its shadow will be less. And this ratio constant is same for all objects at a specific time in the day. And this constant will vary at various times in the day, during the day. Another example is a distance traveled by a vehicle. Suppose a vehicle is traveling at a constant speed or at a uniform speed. That is, let's say it is moving at let's say 10 kilometer per hour or something, 20 kilometer per hour. It is moving at a constant speed. In that situation, the distance traveled by the vehicle and the time for which it has traveled, these two quantities are in direct variation. That is, the distance traveled by the car will be more in more amount of time. If the vehicle is traveling for 1 minute, it will, let's say, it will cover 5 kilometers, and definitely it will cover more in an hour. So distance traveled by a vehicle and the time duration of travel is these two quantities of a vehicle running at a constant speed are vary directly, or they are in direct variation or proportion. Another example is number of men at work and the amount of work done in a day of all those men. Let's say, so if M is the number of men working for a particular type of job, this is for a particular type of task. Some men are working to complete a particular type of task, and M number of men are working. So in a day, the amount of work, let's say the amount of work done is W. So if you increase to do the same kind of job or task, if you increase the number of men, then the more work will be done. That is, W will increase. And if you decrease the number of men, then less number of work will be done. So that is, W will decrease. This is another example. So this is all about two quantities in direct variation or in direct proportion. Now I think the basic concept is that if you identify the two quantities which are in direct variation or proportion, then the ratio of those quantities will remain same. Now if those quantities are A and B, you can say that either A by B is a constant or B by A is a constant. Both are correct. Okay, now the problems. Okay, now let's see the problems of exercise 9A. I hope you can read the problems. It could the fonts are very small. You might not be able to see it properly. I'm sorry for that, but I will read the problem anyway. So now in the book, all these kinds of problems are solved using unitary method. That is, you are given the value of some amount of quantity. From there, you will find first the value of unit amount of that unit quantity of that commodity, and then from the unit price, I mean the price of the value of the unit amount of the commodity, you will find what is asked, that is a certain quantity of that commodity. Let's solve one problem, then you will understand. So let's solve exercise 9A. The first problem is that if 15 oranges cost rupees 110, what do 39 oranges cost? So the fact given is that 15 oranges costs rupees 110. So it is asking 39 oranges will cost how many rupees? Now in the textbook, the way since the first you have to understand very clearly that the number of oranges and its cost and the cost of those number of oranges are in direct proportion. are in direct proportion. That is, if you increase the number of oranges, the cost will increase, and if you decrease the number of oranges, the cost will decrease. Conversely, reversely, you can say, if you have more money, you will have more number of oranges, and if you have less money, you will have less number of oranges. First, you have to understand this very clearly. Since we are only discussing about direct proportion or variation, all these problems, the quantities will be in direct proportion. But once we will also complete the next topic, which is inverse variation or proportion, then when we will do problems on the concepts of both direct and inverse variation, then it might be tricky or tough to decide, to understand whether the two quantities are varying directly or inversely. Anyway, so now, so the way in the book it is solved is that in the book you will see, if you see the examples, the way it solves the problems like this is that using unitary method. So from the fact that 15 oranges costs rupees 110, and since we know that these two quantities, the number of oranges and the cost, are in direct proportion or variation, we know that this will imply that one orange will cost rupees 110 by 15. That is 110. 110 rupees 110 by 15. Now, therefore, it has asked to find the cost of 39 oranges. So, therefore, 39 oranges will cost, since we know that 1 unit of orange, that is 1 orange, costs rupees 110 by 15, then 39 oranges will cost this unit cost, that is cost of 1 orange multiplied by the number of orange, that is 39 into, this will be rupees 110 by 15 into 39. Now, this is how much? 3, 1, 3, 5, and this goes with 22. So 22 into 13, 22 into 13 is how much? 66, and 22, that is 286. So this is rupees 286. So the cost of 39 oranges is 286. This is the method of solving using unitary method. Now, if you apply the concept of two quantities in direct variation or proportion, we said that, so let's say if the n is the number of oranges, if we represent n as the number of oranges and the cost as c, then we know that n by c is a constant. I am representing the constant with k. It will be some constant. This basically means that let's say, so if the number of oranges is n1, and the cost of n1 oranges is c1, and the cost of n2 oranges is c2, then these two ratio should be equal. This is what it means, that the quantity, number of oranges, and its cost, they vary directly, or their ratio is constant. That is, n by c is a constant. This actually means that if the cost of n1 number of oranges is c1 and the cost of n2 number of oranges is c2, then n1 by c1 will be equal to n2 by c2. Now, if we apply this concept, let's say, if we assume that let 39 oranges cost x, actually rupees x, cost rupees x, cost rupees x. Now, so we know that 50 oranges cost rupees 110. And now we are assuming that 39 oranges cost rupees X. So we will have, using this concept or formula, you can say, we can have that 15 by 110 equals 39 by X. Solving this equation or doing cross product, we will see that X equals 110 by 15 into 39. This is exactly the expression that we solved using the unitary method. So this is nothing but rupees 286. So these are the two ways you can solve this kind of problems. The first one is using unitary method, and the second one, that is the concept of N1 by C1 equals to N2 by C2, where the two quantities are N and C and they vary directly. We can say that N by C, or you can say C by N. You can also consider C by N. That will also be fine. So in that case, C1 by N1 will be equal to C2 by N2. So using this formula, when you will apply this formula, you will know some of these quantities will be known. So N1, C1 will be known, and N2 will be known, and you have to find the unknown one from this equation. Okay, let's see the problem number 2. It says that if 8 kg sugar costs rupees 260, how much sugar can be bought for rupees 877.50? Okay, so 8 kg, it is given that 8 kg sugar costs rupees 260. So let's say I am considering representing the cost as C, and the amount of sugar as S. Okay, so this fact is given, and it is asking how much sugar can be bought for rupees 877.50. So let's say X kg sugar can be bought for rupees 877.50. Now for the rest of the problems, I will use the concept of the direct variation, that is N by C will be a constant. I will use the second method, not the unitary method. Okay, since I know that the amount of sugar and the cost of that amount of sugar, they vary directly. Okay, now from these two facts, I know that 8 by 260, basically the concept is that S by C is a constant, will be constant. So this implies that if that S1 amount of sugar, if it costs C1, this will be equal to S2 amount of sugar if it costs is C2. Now therefore, applying this concept, if you apply this concept for this problem, we get that S1 is 8 and its cost is given to be 260, will be equal to S2 is, we have assumed to be X, and its cost is given as 877.50. So from here we can say that X equals 877.50 multiplied by 8 divided by 260. Okay. So now 24. Okay, if I divide this, we have to simplify this. This is 4, 2, this is 4, 6, 24, 5, and if I divide this by 5, this is 13, and this is 1, 7, 35, 5, 5. Okay, and 13, 4, 45, 36. Okay, so this is 175.5 into 2 by 13. This is 10. This is 10, 11, 15. I think this is 351 by 13. I might do some calculation mistake. If I am doing any calculation mistake, please do let me know in the comment section. I will appreciate that because I am prone to make mistakes. I will not really focus in doing any calculation mistakes and finding the answer to be incorrect. I am just focusing on the process and the concepts and how you will apply the concepts to solve the problem. So now x is 351 by 13, and I don't know what this will be. If I divide 351 by 13, this is 2, 26, this is 5, 1. So this is again 3, 39, and this is 12, point 0, 0. 9, 3. Okay, so I mean roughly it is 23.9. So x is 23.9, and what is x? X we have assumed to be amount of sugar that can be in kg, that can be had, that can be bought for rupees 877.50. So this amount of this kg of sugar can be bought. Okay, let's do question number 3. The cost of 37 meter of silk is rupees 6290. What length of this silk can be purchased for rupees 4420? So length, the quantity are length of silk and cost of L length of silk, that is C. So definitely we will have L by C is a constant. This implies if L1 length of silk costs C1, this will be equal to L2 length of silk costing C2. So it has given that 37 meter of silk costs rupees 6290, and it has asked what length of silk can be purchased for rupees 4420. So let's say x meter of silk can be purchased for rupees 4420. Now using the concept of direct proportion or direct variation, we can say that 37 by 6290 will be equal to x by 4420. From here we can say that x equals 4420 multiplied by 37 divided by 6290. 0 cancels, and this is a long simplification. 9, 7, 7, 8, 56, 69. No, I have no idea. 37, 7. 37, will 37 divide 629? 1, 37, 5, 2, 9. Is this 7? Yes, this is 7. So 17. 17. And will 17 divide 442? Mm, 3, no, 2, 34, 2, 6, yes, 6. So this is 26. So the answer is 26 meter of silk can be purchased for rupees 4420. Okay, I hope the concept of applying the ratio is a constant. You are understanding the concept that if two quantities are direct, if they vary directly, that is, they are in direct variation or proportion, then the ratio is will always remain constant. So in this kind of problems, the actual value of those two quantities will be given. From there, you can have the ratio. You can find the ratio, and some one value of one quantity will be given, and you have to find the value of the other quantity in using the constant. This is the basic concept. Let's see question number 4. It says a worker is paid rupees 1110 for 6 days. A worker is paid rupees 1100 for 6 days. If his total wages during a month, are 4625, for how many days did he work? So definitely the number of days and the payment are in direct proportion. So number of days, let's say D, number of days worked, and the two quantities here are number of days worked and uh, amount paid, that is the wage. Amount paid, let's say P, amount paid, that is wages. These two quantities are in direct proportion, because if a worker works for more number of days, definitely he will be paid more, and if he works less number of days, he will be paid less. So we can say that D by P is constant. I mean, if the worker works for D number of days, and if he is paid P, then D by P will be constant. So one fact is given, that the worker is paid rupees 1110 for 6 days. So 6 days, the worker is paid rupees 1110, and it is asking if his total wages during a month are rupees 4625, for how many days did he work? Let's say he has worked 6 x days. Let's say the worker has worked x days, for which he was paid rupees 4625. So now we can say that, using the fact that D by P will always be constant, we can say that 6 by 1110 will be equal to x by 4625. This implies, from here we can say that x equals 4625 multiplied by 6 divided by 1110. Now, 4, 4, 4. How much this will be? Let's divide by 5. This is 5, 2, 2, 2, I guess, 10. Yes, and this divides by 9. 2 and 5. If his total wages during a month, for how many days did he work? So definitely this value of x has to be an integer. It should be an integer. So if I divide 6 by 2, this is 3, this is 1, 1, 1. Okay, so 3 now again divides 111 with 3, 3, 9, 7, 37. And will 37 divide 925? 3, 2, 14, 7, this is 8, 1, 5, and I guess 5, yes. So 25, so this is 25. So if the worker works for 25 days, then he will be paid rupees 4625. So this is the answer. Okay, let's see question number 5. It says that a car can cover a distance of 357 kilometer on 42 liters of petrol. How far can it travel on 12 liters of petrol? So these are all similar kind of problem. The only thing is that you have to understand clearly that what are the two quantities, and that they are varying, that they vary directly. And then you can apply the concept of the ratio will be same, and you will have the equation, the quantity that has been asked. If you consider that, assume that to be x, you will get an equation in that unknown quantity x, and then you can easily solve it. Okay, so question number 5, the quantities are a car can cover a distance. So distance covered. So now I will not be writing in details. I'm trying to solve the problems in a very compact form, since I think you have already understood the concept that I'm applying to solve the problems. That is using the direct variation. Two quantities are in direct variation or proportion, and so their ratio will always be same. This is the basic concept I'm applying to solve the problems. So it is given that a car can cover a distance of 357 kilometer and 42 liters of petrol. So the quantities here are distance covered and the amount of petrol. So if the amount of petrol is more, definitely the car will cover more distance, and if the amount of petrol is less, it will cover less distance. So distance covered and the amount of petrol, or the liters of petrol, are in direct proportion. So it is given that 357 kilometer is covered in 42 liters of petrol. Okay, now let's what is asked, how far it can travel on 12 liters of petrol. Let's say x kilometer is traveled on using 12 liters of petrol. So this implies, using the concept of the ratio remains the same, we can say 357 by 42 equals x by 12. Now this implies x equals 357 multiplied by 12 divided by 42. Now 3, 4 and 3, 1, 14. Or rather, okay, so 2, 7 and 7 divides by 51. So this is 210. So the answer is 102 kilometer will be covered by the car. If it uses in 12 liters of petrol, the car will cover 102 kilometer. Where it was given that in 42 liters of petrol, it covers 357 kilometer. Okay. Let's do problem number 6. How many problems are there? 15. Okay. Traveling 900 kilometer by rail costs rupees 2520. Traveling 900 kilometer by rail costs what would be the fare for a journey of 360 kilometer when a person travels by the same class? Now, if you are traveling in a rail, definitely the cost varies from class to class. So it is talking about a particular class. So if you are traveling by rail in a particular class, then the more distance you will travel, definitely the cost will be more. So here the distance traveled and the cost uh, is in direct proportion or in direct variation. So it is given that 900 kilometer to travel by rail, traveling by rail 900 kilometer, when you travel by rail 900 kilometer, the cost is given to be 2520. Now it has asked what would be the fare for a journey of 360 kilometer. Okay, so let's say 360 kilometer, if we travel by rail in the same class 360 kilometer, let's say we'll assume the cost to be rupees x. Whatever it is asking, we will assume that to be x. Okay. Now, using the concept of that ratio remains same, we can say that 900 divided by 2520 will be equal to 360 by x. This implies x will be equal to 2520 multiplied by 360 divided by 900. Okay, so 20 cancels out and this is divides by 4, and so this is equal 8, 20 and 10. So the cost of 360 kilometer, the cost of traveling by rail in the same class, traveling 360 kilometer in the same class will cost rupees 1008. 1008. This is the answer. Now, if I do any calculation mistakes, please do let me know in the comment section. I will appreciate that. I'm not really focusing in any kind of calculation mistakes. Okay. So, but if I am making any mistakes in the concept, applying the concept in solving the problem, then please do let me know in the comment section. Question number 7 says a train covers a distance of 51 km in 45 minutes. How long will it take to cover 221 km? So the quantities over here are distance covered and duration of duration. So the quantities are a distance, but please keep in mind that the train is traveling at a constant speed. So distance, d, and duration, for how long the train is traveling. So it has given that 51 kilometer is covered by the train in the time taken is 45 minutes. 45 minutes. Now it has asked that how long will it take to cover 221 kilometer. So let's say 221 kilometer will be covered by the train in x minute. Therefore, we can say, using the concept of two quantities in direct proportion, the ratio remains the same. Their ratio remains the same. We can say that 51 by 45 equals 221 by x. This implies, from this we can say that x equals 221 multiplied by 45 divided by 51. This is 3 divides with 17, 3, 15, and I guess yes, 17 will divide 221 by 1 and 3. So this is 13 into 15. 13 into 15 is 65 and 13 195. So this is 195 minutes. So to travel 221 kilometer, the train will take 195 minutes. Okay, let's see question number 8. It says if 22.5 meters of a uniform iron rod weighs 85.5 kg, what will be the length of 22.8 kg of the same rod? Okay, so we can see that the length of rod, the quantities length of the rod and the weight of rod, they are in direct proportion. This is because the density of the rod is same. If the density of the rod is like the weight of the rod divided by its volume, it not volume actually, I mean that the density of the rod throughout its length is same. That is the reason these two quantities are in direct proportion. So if you increase the length, the weight will increase, and if you decrease the length, the weight will decrease. So now the one fact is given is that 22.5 meter of the uniform rod, by uniform rod means its density is uniform, its weight is 85.5 kg. It has asked what will be the length of 22.8 kg of the same rod. Let's say length. So let's say the length will be x meter. So let's say x meter of that uniform rod, its weight will be 22.8 kg. So now applying the concept of two quantities in direct variation, that the ratio remains the same, we can say that 22.5 divided by 85.5 equals x by 22.8. This implies that x equals 22.8 multiplied by 22.5 divided by 85.5. Now these are some division of decimals. It's better that you convert the decimals into fractions. So 22.8 is nothing but 228 divided by 10 multiplied by 22.5 is nothing but 225 divided by 10, and this whole is divided by 85.5 means 855 by 10. If you simplify this, it will become 228 multiplied by 225 by 855 multiplied by 10. Now if you simplify this, okay, so 5 divides 10 2, and this is 545. 2 divides 28 with 1 1 4, and 45 I guess will divide 855 with 1, then 40 405 405 9. So 114 divided by 19. So this is 114 divided by 19. So this meter of, I'm not converting it into a decimal. Now you can do it. If you divide 114 by 19, what do you get? 6. Oh, it divides, I think it divides with 6. 9, 6, 54. Oh, divides perfectly. So this is 6. So this is 6 meter. So the answer is 6 meter. 6 meter of the rod will weight, the weight of the 6 meter of this uniform rod will weight 22.8 kg. So the answer is 6 meter. Okay. Let's do problem number 9. If the weight of 6 sheets of a paper is 162 grams, how many sheets of the same quantity of paper would weigh 13.15 kg? So you have to be careful with the units. So so the number of sheets. So it is given that 6 sheets. The weight of 6 sheets of the paper is 162 gram, and it is asking how many sheets of the same quantity of paper would weigh 13.5 kg. So let's say X sheets will weigh now 13.5 kg. We should convert it to gram. So that is 13,500 gram. So 1 kg is 1000 gram. So 13.5 kg is 13,13500 gram. So now we can apply the concept of the ratio is constant and say that 6 by 162 equals x by 13500. This implies x equals 13500 into 6 divided by 162. So this divides with 627 and 27 135. So this divides with 500. So this is x 500 sheets. 500 sheets of the paper will weigh 13.5 kg. Okay. Let's do problem number 10. It says 1152 1152 bars of soap can be packed in 8 cartons of the same size. Okay, how many such cartons will be required to pack 3888 bars? How many such cartons? So definitely the size of the cartons and the capacity of all the cartons is same. That is, the number of bars that can be stored in one carton is the same. Okay, so it is said that now you have to understand the quantities that are in direct proportion. The number of cartons, since the cartons are of same size, each carton can store same number of bars. So the quantities here are number of bars and number of cartons. So definitely if there are more cartons you can store more bars, and if there are less cartons you can store less bars. So it is given that 1152 soaps can be packed in 8 cartons. 8 cartons. It has asked how many such cartons will be required to pack 3888 bars. So let's say 3888 soaps. Actually, this is not soaps, bar. This is bars. So this will be bars. Let's say 3888 bars can be stored in X cartons. Then X number of cartons. So now we can say that 1152 divided by 8 is equal to 3888 divided by x. This implies x equals 3888 multiplied by 8 divided by 1152. Okay, So we have to simplify this. Let's see if 8 divides 1152 or not. 1 and 35. 4. And let's see if 144 divides 3, 8, 8, 8 or not. 3, 12, no. 2, 2, 8, 8, 1, 0, 0 and 8. Okay. I guess it will then divide by 7. 28, 28, 30, yes. So this is 27. So 3888 bars can be stored in 27 cartons. So this is the answer. Problem number 11. If the thickness of a pile of 16 cardboards, is 44 millimeter, how many cardboards will be there in a pile which is 71.5 centimeter thick? So definitely if there are piles of cardboards, these are piles of cardboards, so this is the thickness of the piles of cardboards, T, and the number of cardboards is N. So the number of cardboards and the thickness of when the cardboards are piled up, the thickness of that pile, they are in direct proportion. That is, if there are more number of cardboards, definitely the thickness will be more, and if there are less number of cardboards, the thickness will be less. So the fact given is that 16 cardboards its thickness is 44 millimeter. You have to be very careful with the units. Whenever you work with the ratio, you always convert both the terms of ratio in the same unit. So it is given that 16 cardboards, the pile of 16 cardboards, the thickness is 44 millimeter, and it is asking how many cardboards will be there in a pile which is 71.5 centimeter thick. Okay, so let's say X number of cardboards is its thickness will be 71.5 centimeter. We have to convert this into millimeter. So that is 715 millimeter. If I am not wrong, 1 centimeter equals 10 millimeter. So 71.5 centimeter is 715 millimeter. Okay. So now we can say that 16 by 44 equals X by 715. This implies X equals 715 multiplied by 16 divided by 44. So 4 divides 44 with 11 and divides 16 with 4, and this 11 divides 715 with 65. Okay, so 65 into 4, that is 20, 260. So 260 cardboards, the pile of 260 cardboards, its thickness will be 715 millimeter. So the answer is 260. Okay. Let's do problem number 12. At a particular time of a day, a 7-meter high flagstaff casts a shadow which is 8.2 meter long. What is the height of the building which casts a shadow 20.5 meters in length at the same moment? So I have already discussed discussing some examples of the two quantities in direct proportion. So we know that the height of an object at a specific time, the height of any object and its the length of its shadow that is casted by the sunlight, the ratio is same. The ratio of the height and the length of the shadow is same of all objects during a specific time in the day. So it has given that for a Flagstaff 7 meter, for the object Flagstaff it is given 7 meter, it is casting a shadow of 8.2 meter. So this is, let's say, height considering, so the left hand side is height, this is the shadow, length of the shadow. So one fact is given about a Flagstaff is that 7 meter high Flagstaff casts the shadow of 8.2 meter. Now it is asking for a building, what is the height of the building which casts a shadow of 20.5 meters in length. So let's say the height of the building is x meter. So x meter building is casting a shadow of length 20.5 meter, and we know that the ratio 7 by 8.2 will be same as the ratio x by 20.5. This implies x equals 20.5 multiplied by 7 divided by 8.2. If you convert the decimals to fractions, it will become 205 by 10 multiplied by 7 divided by 82 by 10. This equals to 205 multiplied by 7 divided by 82. Now 7963. Okay. 82. 25 and 82. 7 meter high Flagstaff casts a shadow of 8.2 meter long. Okay. And it is asking what is the height of the building which casts a shadow of 20.5 meters in length. Okay. 20.5. So 7 by 8.2 should be equal to x by 20.5. So x equals, okay, so for 3, 7, 46. So this is equals to we have to simplify this. Now 205 into 7 is 35, 3, 14 by 82. This equals, if you do the division, 1, 4, 3, 5, 82, 1, 82, 1, 6, 5, 7, 14, 57, this is 1, this is 4, then 0.0, 5, 10, 41, 0. So this is 17.5. So the answer is 17.5 meter. The height of the building will be 17.5 meter. Okay. Let's do question number 13. It says 15 men can build a 16.25 meter long wall up to a certain height. 15 men can build a 16.25 25-meter long wall up to a certain height in one day, how many men should be employed to build a wall of the same height but of length 26 meters in one day? 15 men can build a 16.25 meter long wall. 16 men can build a 16.25 meter long wall up to a certain height in one day. How many men should be employed to build a wall of the same height? How many men should be employed to build a wall of the same height but of length 26 meters in one day? Okay, so basically it is saying that there is a wall, kind of this. It's this. Let's say this is the wall. This is the wall. This is the wall. So the length. Let's say the length of the wall is L, and the height of the wall is H. Now, it is saying the first fact given is that 15 men can build a 16.25 meter long, this L is 16.25 meter long wall up to a certain height in one day. Up to a certain height. We don't know the height is not given. Let's say the height is H. Let's say the height is H. Now, how many men should be employed to build a wall of the same height, but of length 26 meters in one day? So the fact given is that in one day, 15 men can build a 16.25 meter long wall up to a certain height. So how many men should be employed to build the wall? How many men should be employed that in one day that can build the wall of the same height but of different length? So basically in this situation, since the height is fixed and the day in one day is fixed, so definitely we can say that number of men for this problem, number of men and the length of wall are in direct proportion. Since the height is fixed, the more and also the number of days is fixed in one day. So to build the wall of same height but of greater length, more men will be needed to build that wall of the same height but of more length in one day, and less number of men will be required to build that same wall of the same height in one day but of lesser length. So the number of men and the length of wall are in direct proportion. So we will apply the concept of the ratio will be same. So one fact is given is that 15 men is required to build the wall of 16.25 meter of certain height. We are not really bothered about the height because it is fixed. Now it is asking how many men should be employed to build a wall of the same height but of length 26 meters in one day. So let's say X men is required to build the same wall of same height but of length 26 meter. Therefore, we have 15 by 16.25 equals X by 26. This implies X equals 26 multiplied by 15 divided by 16.25. This is 26 multiplied by 15 into 100 divided by 16, 162, 5. Now I guess 15 will divide 1625. Let's see, 1, 0, 1, 15, 125, 125. Now, let's see, let's divide step by step. 5 divides 15 by 3, and 5 divides 1625 with 3, 25. Okay. So now 26, 1625. 15 men can build 16.225 and X men can build 26 meters. Okay. 15 by 16.25 equals X by 26. This implies X equals to 26 into 15 divided by 16.25. Okay. Now 1 so this is equals 78 3 to 5. So 3 to 5, let's divide 7, 8, 0, 0. 2, 10, 6, 0, 3, 1, 0, 4. We will divide by 4, 20, 10, yes. So this is 24. So 24 men will be required to build the wall of length 26 meters and same height in one day. So the answer is 24. Let's do question number 14. In a hospital, the monthly consumption of milk of 60 patients is 1350 liters. Monthly consumption of milk. I mean the total number of the amount of milk in 1 month, the amount of milk consumed by 60 patients is 1350 liters. Is 1350 liters. Okay. How many patients can be accommodated in the hospital if the monthly ration of milk is raised to 1710 liters, assuming that the quota per head remains the same? Assuming that the quota per head remains the same. How many patients can be accommodated in the hospital if the monthly ration of milk is raised to? Okay, so initially, so the fact given is that 60 patients was consuming 1350 liters of milk. 10 liters of milk. How many patients can be accommodated if the monthly ration of milk means the monthly consumption, if it is increased from 1350 to 1710 liters, then how many patients can be accommodated? Considering the fact that the consumption of each patient monthly is same. Assuming that the quota per head remains the same, means quota per head means the amount of milk that a single patient consumes in a month. So from this we can say that 60 patients consumes in a month 1350 liters of milk. This implies that one patient now Okay, so it has already said that. Okay, so one standard way using the unitary method is that one patient consumes uh, 1350 divided by 60 liters of milk. This is equals uh, this equals 45 by 2 liters of milk. 45 by 2 liters of milk. One patient is consuming 45 by 2 liters of milk initially. Okay, so now it is asking how many patients can be accommodated in the hospital if the monthly ration of milk is raised to 1710 liters. So let's say X patients, if we assume that X patients has been accommodated and they are consuming 1710 liters of milk per month. Now, if this is so, then we know that the consumption of milk per head is same, which we have already found out to be 45 by 2. From this fact, now if X patients are accommodated in the hospital, we know that if X patients are accommodated in the hospital, then now we know that since it is given that the consumption of milk per patient is same monthly basis, and which we have found to be 45 by 2 liters of milk is consumed per patient in 1 month. So if we assume that X patients can be accommodated in the hospital and they are consuming they can be accommodated so that they total consume 1710 liters of milk, then X patients will consume how much? 45 by 2 into X liters of milk, because one patient is consuming 45 by 2 liters of milk per month. This consumption of milk of one patient remains the same. So if X patients are accommodated in the hospital, then in 1 month X patients will consume 45 by 2 into X liters of milk. Therefore, this implies, and it has already given, that the total consumption is raised to 1710 liters of milk. So we can say that 45 by 2 into X equals 1710 liters of milk, because we have assumed that X patients can be accommodated in the hospital so that they will consume 1710 liters of milk in 1 month. So this implies X equals 1710 into 2 divided by 45. So these liters of milk will be consumed, and we have to simplify this. 5, 9 and 5, 3, 4, 2, and 9. This 9 divides 342, 9, 3, 27, 7, 72. So this is 76 liters of milk. 76 liters of milk is the answer. Sorry, not liters of milk. This is 76 patients. So 76 patients can be accommodated where they are consuming 1710 liters of milk. So here the constant is that the consumption of milk per patient in a month is same, and we have found that consumption from the first given data, that is 60 patients is consuming 1350 liters of milk. From there we have found that one patient consumes 45 by 2 liters of milk. This consumption will per patient will remain constant. So using this fact, we have found how many patients can be accommodated if the total consumption given is 1710 liters. Okay, let's do the last problem, that is problem number 15. It says that the extension in an elastic string varies directly as the weight hung on it. Okay, so kind of this, the weight is hung, and this is a string. It is hung from some wall or whatever, ceiling, and it is saying that the extension, so kind of, if this is the wall, the string was like this and it got extended. Let's say this one, this portion, this is the extension length, and this is the string, and it got, when the weight was hung, W, if W represents the weight of the some object, then, and the L is the extension of the string due to this weight, then it is saying that L and W varies directly. So L by W will be constant. If you increase the weight, the extension will be more, and if you decrease the weight, the extension will be less. Okay, so if a weight 150 gram produces an extension of 2.8 centimeter, so 150 gram is producing an extension of 2.8 centimeter. What weight would produce an extension of 19.6 centimeter? So let's say a weight of X gram will produce an extension of 19.6 centimeter. So therefore we can say that 150 divided by 2.8 equals X by 19.6, where we know that W by L will be constant. Since W and L are directly or varies directly, that is, they are in direct proportion or variation, W by L will be constant. So in the first case, W by L is 150 by 2.8, and in the second case, W by L is X by 19.6, and they are equal. From here we can say X equals 150 multiplied by 19.6 divided by 2.8. This is 150 multiplied by 196 divided by 28. 7 divides 28 with 4, and 28. And this divides again with 7. Okay, so this is 150 into 7, and this is 1050. So 1050 gram will be, so it is asking what weight would produce an extension of 19.6 centimeter. So 1050 gram, or this is equals to 1.05 kg of the weight will produce an extension of 19.6. Okay. So this brings to the end of solving all the problems of exercise 9A, which was based on the concept of two quantities that varies directly or in direct variation or direct proportion. So I hope this video was beneficial to you, solving all the problems and applying the concept of the ratio of two quantities that vary directly remains the same, applying this concept, and also the concept of unitary method that I used in some problems, few problems. I hope you will get a good understanding of how, a good understanding on the concept of two quantities that vary directly, and how to use that concept to solve this kind of problem. If this video was beneficial, then please like it, share it with your friends, and also once again please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So in the next video I will discuss about two quantities that vary inversely. That is, we will talk about inverse variation and solve the problems of 9b, and then after that we will solve the objective questions, that is the MCQ, and we'll solve the test paper 9. So please stay tuned for the upcoming videos on this chapter. So thanks for watching, and until the next video, take care and bye.